So, the subject at hand. The Junkers J1 586-18 that is held in, actually used to be stored for decades, currently on display at the Canada Aviation and Space Museum in Ottawa, Ontario, Canada. As I mentioned earlier, I have two reasons for wanting to talk about this aircraft. The first one is that most of the people I know who know me with early aviation always identify me with Fokker D7 and nothing else. So I wanted to give some sense that I had been exposed to other aircraft. And I also want to actually promote what I think is one of the better aviation museums in the world, which is the Canada Aviation and Space Museum in Ottawa. Specifically for World War I-centric people, they have some unique aircraft that you can't see anywhere. The J1 is an example. Well, there is one other fuselage in existence. This is the only intact, complete, sorry, minus one part, the spinner, J1 to survive the war. Ottawa also has on display the AEG G4, which is the only multi-engine German bomber to survive World War I to this day. They are both on the floor currently in Ottawa. Other interesting aircraft is the Camel 2F2, which as far as I know is one of the only, if not the only, naval version of a Camel in existence. Sowerby VC's BE2, Zeppelin shooting down, is sitting uncovered on the floor so you can examine the structure closely. Anyways, I'll encourage you to do what I didn't do, which is get in your car and drive for 10 hours that away. So, Junk 1, which as you can see, this is printed off the upper wing. This is how it's identified all the way through. A quick word on Hugo Junkers. Bunch of information there to keep this brief. The interesting thing to me about Hugo Junkers is he got into aviation very late in life. He was 50 when he started exploring aviation. He had made his money on patents relating mostly to heat exchange. It's probably the simplest way to put it. Calorimeter, tankless water heaters, i.e. on-demand water heater systems. And from the money he derived from that, he did a huge amount of research and experimentation to prove mathematical models that he developed. Aviation, as I mentioned, is something he didn't start until he was 50, 1909. And he started doing a lot of research, and his research led him to believe, or brought him to the conclusion of thick aspect wings, monoplanes, not biplanes. Why would you ever want a monoplane? Cantilever wings, and metal construction. What is interesting about Hugo Junkers is he was removed out of his own company in the mid-1930s, and it seems to be primarily because he would not become a member of the National Socialist Party at the time, and he was replaced, and he died within a year after being removed from the company that he had founded. This is an early factory drawing of a prototype J1. By the way, I'm going to use the military terminology of J1 as opposed to the Junkers terminology of J4, which is their fourth basic design. It's one of those things that always throws me, where we have two virtually similar seeming things. As most people will know, the J1 was the original Dessau donkey. It was his first all-metal monoplane, and because duraluminum, or high tensile strength aluminum, was earmarked purely for the Zeppelin program, he built an airplane entirely out of steel that flew in 1914. 1914. So it's interesting. What's different basically between this drawing and the other you'll see will be in the shape of the rudder and the fin. So, J1, I have to be careful of this because John's in the audience, but in 1917 the German military came up with a new designation of aircraft, which was the Jagdflugzeuge, which was, I mean, the translation would be hunter aircraft. their intent was to come up with a robust, i.e. an armored aircraft that could provide close tactical support to ground troops. It wasn't really meant as an attack aircraft, the way we would think of today. It was to provide close communications between artillery and troops at the front to be as impervious to ground fire as possible to be able to provide that support, and this communications was by radio. And it wasn't dropping streamers or messages or anything else, and it was a fairly late war thing.
Was that voice radio by then? Or just long wave
No,
code? Okay, that's what I thought.
Telefunken, mostly, equipment on these aircraft.
Morse code.
no, it's two transmission, not spark.
This specific aircraft that I'm talking about, so I'm not going to be able to answer every question you have about a J1, but I can answer a question specific to 586-18. So 586-18 was captured at Villiers-le-Chevre by the U.S. forces in 1918. And here we have a picture of it on the ground. This is quite a well-known photo. You can see the rear fabric fuselage, and just a quick note of structure. It's armor from there to that line, and then fabric covered from here back. When I mentioned there was a difference in the shape of the fin and the rudder, basically what they've done is that the fin has been, it's actually increased slightly in area. This angle is a little more abrupt, but they also have an aerodynamic balance now on the rudder, which they didn't have on the prototype version. But this is one of the earliest photos of 586-18. It went from Villiers-le-Chevre, it went to Dieppe. Other Canadian war trophy aircraft were based at Hounslow in the UK, and they were shipped in May 1919 to Canada. And the freighter that brought other aircraft, such as the Knowlton Fokker D7, to Canada stopped in Dieppe and picked up this and other aircraft at the time, came across the ocean, took them to the port of Montreal, and then from Montreal they went to the Toronto area. This photograph is taken in summer of 1919 at the Canadian National Exhibition in Toronto, Ontario, Canada, and this is setting up the exhibit, and the J1 was one of the prime objects. This was considered, I mean, compared to any other aircraft out there, this huge steel monocoque at the front, this all-metal structure. You will note, by the way, even by this time, every inch of fabric is off the aft and has been souvenired off the aft of the fuselage. Like most people think of Fokker and cantilever wings, they were all Junker-proven theories, and the J1 is similar in build with cantilever wings and just inboard struts. Unlike the D7 and the D6, it doesn't have outboard end struts involved. After it went on its war trophy tour through Canada, it ended up in a basement. I don't have a picture. We haven't yet to be able to find a picture of it in the basement. But part of Canada's war trophy program was to create a series of buildings in the nation's capital in Ottawa to commemorate the Great War. And the war trophies were supposed to be the centerpiece of this. And there were 5 buildings defined to have been built, of which only 1 was actually built. But they did build an annex to that building where they put everything. And I love this photograph. While it doesn't show the J1, we have the AEG fuselage sitting over here. This pile that looks like cordwood is all 0815s. Trench mortar here. This mortar is a wire and steel banded wood trench mortar of about 400 millimeters diameter, and that still is on display at the Knowlton Museum in rural Quebec. Anyways, it was an interesting thing, and in what I call preservation through benign neglect, the AEG and the Junkers J1 survived the next series of decades because they were out of sight, out of mind. Basically in the basement of this annex. Nobody saw them, nobody thought of them, nobody worried about them. The airplane was turned over. It was decided that it was, quote, owned by the Royal Canadian Air Force. And when the National Aeronautical Collection was created in the 1960s, it was turned over to them and then immediately put into storage. This is how I first saw it. It's in storage in a building, jammed up with a bunch of other aircraft. The wings aren't on it. This is the center section that you're seeing here. Nice layer of dust on it. And that's the way it sat basically from the 1960s until last summer, when for the first time ever it was put on public display in the museum. And here it is last fall, sitting next to the AEG on the floor. It's a good photograph because you can clearly see the steel front structure, the Benz BZ4A motor in the front, the wheels, which are off a 1950s jet. The original wheels do exist, by the way. We did find them. They are 3 rows of spokes with the correct diameter. No tires for them. And so at this time, they're still leaving it the way it is. This is the propeller that it was shipped with. It appears it conforms to the diameter and pitch defined for it. And it looks extremely beat up. There's evidence of damage all along it, and a little later I'll explain why that exists. So, the structure, the reason for the damage is that the airplane is unbelievably delicate for what's supposed to be a bulletproof airplane, or because it's a bulletproof airplane. So the basic structure from the back, this back curve of the observer's cockpit to the front bulkhead in front of the motor is 5mm steel plate. It is a monocoque. There are 3 bulkheads in there, formed in different ways. It's done with steel plates that are flush fitting on the outside, riveted together with stiffeners in behind them. Extremely well made. 95 years later, it's still extremely smooth on the outside. The aft section of it is all aluminum tube, no wire bracing, braced with other aluminum tubes. And this little dashed line that you see here, the only wood on the airframe itself is formers to flesh out the shape for aerodynamic reasons for where the fabric covered over the aircraft. So, blah, 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 blah. Here's, yeah, I've got 12 seconds to slide. This is a photograph that shows the front tub. It gives you a good example of how it's done. This is really the front bulkhead here. These doors are not really part of the monocoque, as you can tell, but it gives fascinating access to the motor. They both go right back at 90 degrees, but I did wonder a little bit about the idea to make basically suicide doors on an airplane. I have no reports that a front latch ever let go or something, but you can imagine how disastrous that would have been. And there's the airplane on display giving basically the equivalent picture. So what's missing on this airplane, what you won't see, is the exhaust manifold, which they haven't been able to determine where it is. They believe it's in stores somewhere within the federal government, but haven't been able to discover it. And what you can't clearly see is the radiator for the cooling system is underslung on the upper wing. And it's a fascinating little bit of technology itself because it actually has a Venturi-shaped metal cowl around it to accelerate the airflow through. Until I started looking at this airplane, I had always been told, being more or less British by descent, that what's his name, the designer of the Supermarine Spitfire, basically came up that, or de Havilland with the Mosquito and their in-wing coolers came up with this Venturi effect to give a little boost on the outside. Enough from that. This may give you an idea of how smooth the fitting is. No welding involved with the steel, and I can't comment on why that wasn't done, but you can see how evenly. This is the door that hinges, and you can see how closely it fits when it's closed. This part of the steel, which almost looks like a smokestack or a funnel, protects the upper part of the engine. So all the protection is basically defined from a ground fire aspect, not from airborne attack. It apparently worked quite well, as far as I'm aware, there is no record of a J-1 aircraft being shot down in active service. A quick view of the stern part of the aircraft, where we have the fin here. You can see the aluminum structure. What I would ask you to note now, because I'm going to refer to it later, is this little aluminum cover here, which is immediately behind the observer's part of the steel fuselage. And there's a better aspect view looking forwards on it. And it's this aluminum area that is interesting as far as its mission went. The rear longerons are aluminum tubes, different diameters, varying wall thicknesses. What I found interesting to this is that in Fokker-built aircraft where steel tubes of decreasing diameter come together, because all the tubing generally increases in 1 millimeter diameters, it's easy to come up with the OD of one tube that is exactly the ID of another and slip it in. That isn't so on this. And you can see what they've done when they've taken the larger tube, they've cut fillets out of it and actually squeezed it square, very much like Hawker did with fittings on the fuselage of a Hawker Hurricane or Hawker Fury, and then put in straight rows of rivets. There's been no attempt to stagger rivets for the pull on it to minimize tear out, though apparently it wasn't a problem. The aluminum to aluminum connections on this are not done the way Robert Basley would with one of his Aerodrome's airplanes or other ultralight planes would be done, which is using aluminum rivets with aluminum gussets and brackets to hold aluminum tubes together. All the fittings are made out of mild sheet steel and riveted together with steel rivets. This did not carry on to later Junkers aircraft in World War I, like the D series of aircraft. They then changed to aluminum rivets. But with the J-1, they're using steel rivets through. You can see the corrosion, but oddly enough, there's virtually no evidence of any kind of galvanic corrosion between the steel and the aluminum used for this. By the way, the aluminum, by the material strength reports that came out of the U.S. Army Engineering Corps in 1919 and 1920 indicate that if you wanted to build one of these in your backyard, you could use 6061's T6 and be pretty safe as far as strength went. This is, to me, a technically interesting part because this is attaching the upper port longeron to the aft of the steel monocoque. And what they've done is they've made a steel fitting, a sleeve on the outside with a thick wall front that has a threaded stud on it. And the threaded stud goes through the back of the monocoque and has a single bolt attaching it on. And a lot of people who maybe don't spend a lot of time hands-on with aircraft go, ooh. But most aircraft motors are held on to the airframes with 4 bolts. Unless you have a round engine, they have more because nothing's even on those things. And you can see in this case, they have used a staggered rivet pattern when they've riveted this on. So once again, a steel fitting onto an aluminum tube. It's a pure tension load on it. And once again, no evidence of any failure. This aluminum panel, by the way, that's a fabric attach point for the fuselage fabric coming forwards. I scratched my head a lot when I first saw this. Where we are on this is at the very aft of the fuselage, just at the start of the empennage, just below where the stabilizer fits. There's additional bracing tubes going up to improve the structure of the fuselage there. But it was this framework here that I couldn't understand, and it took me a while to realize that this complex piece is literally just a lift handle. It's a lift handle for 4 people. It's not a Newport. It's a heavier aircraft. But it's, in a similar sense, something I skipped earlier is that the J1 was the first production aircraft that Junkers was involved in. Any volume production of any type. And it came out specifically from the mandate from the Ildflyg for the creation of JFA, which there's been numerous dialogues about, dialogues before. And my German's not very good, but it's Junkers, Fokker, Gesellschaft. John will improve on that. And it would appear that while a lot of the Junkers theoretical technology was co-opted by Tony Fokker and used in later aircraft, i.e. virtually all his cantilever wing designs, some things from the steel fuselage production world came over, and some of them would be the use of what we would term tube clamps. Mike O'Neill will know them as AM741 clamps, or MS27905, or whatever the heck they are, to use them so that there's no welding involved. Everything is just clamped on, and your 1940 Stearman used the same type of technology for attaching things mid-span in joints. The rear cockpit, which is probably the most interesting part of the airplane from a functional aspect, this tube has nothing to do with it. I wasn't allowed to remove it, but this is the coolant line from the engine up to the radiator, so don't let it confuse you. This part here running off the screen is where I pointed out earlier, pay attention to this aluminum covering between the upper longerons just aft of the observer's cockpit. This is where they carried cameras for recording ground observation. One of the interesting things about this airplane is it was rigged to run an electrically driven cinematography camera. They were doing movie film with electric-driven cameras from this aircraft. I can't swear to it. I would suspect that this electrical junction here was to drive that motor. When they were equipped for the movie camera, they had an additional wind generator attached to the strut on the starboard side of the, port side of the aircraft, specifically to drive the motor for the camera. The most obvious thing missing out of here is the observer seat. There is a shackle there, one down here on this side, 2 chains held up a wood seat squab that the observer sat on. And all the rest of the wood in here was to support bits and pieces of radio communications equipment. Like, oddly enough, for an all-metal airplane, it still has the standard German wood gun ring. You may not be aware of that. Everybody sees lots of pictures of the British and the French rings, which are always metal. The Germans used a wood ring. This would have had a single parabellum, though they carried 1,000 rounds of ammunition for the one gun. As far as armament goes, there were experiments done with forward-firing ground guns for trench strafing. Apparently they were specifically unsuccessful, and they're certainly not part of this aircraft. Another view inside the observer's cockpit looking forwards. This is where the radio equipment actually would have been mounted. Oddly enough, one of the surviving pieces of documentation for this aircraft is a operator's handbook, and it specifically refers to Telefunken equipment being used in the aircraft. Unknowns to me, because I have not spent the time to try to decipher what any of the wiring connections are, is that there's an interesting steel mount here with a nice opening through the floor, but covered by the lower bodywork. So I have no idea what that was for, except for to perhaps mount something inside the aircraft. These leather straps, which were on the back of the observer's cockpit, were used to suspend the cameras. And there's straps here, and there's straps off this bit of covering here, which I unfortunately don't have a good photograph of. The front cockpit, you can see this is a little more damaged than the other. Of note to me, just being curious, is that what you're seeing here, this piece of lumber, that's one of the engine bearers. We have an all-metal airplane, but the engine bearers are ash inside the airplane. I am guessing that it had something to do with vibration isolation, but I can't guarantee that. The throttle would have been here, and it was actually a machined metal throttle, very nice looking, in the photographs that I've seen. This is part of the fuel system, which I'll talk about a bit later. The rudder bar down here, which is a very interesting wavy shaped bent steel tube, and this is the bottom of the control column. Here's the control column. You can just see the grip. It's a slightly angled back two-handed grip on it. There's no evidence of a hand grip throttle like a lot of German aircraft had on it. But this part over here is a little difficult to see. What you have is something coming off the torque tube for the ailerons with a linkage coming up to what is basically a rocker arm that's pivoted at this end. Now that rocker arm horizontally would extend to about here. It's the angle of the cameras distorting the image a fair bit. But exiting the cockpit, all the flying controls were done by push-pull rods. There were no cables inside the cockpit itself for the flying controls. I don't have a good photograph of the fuel tank, but this is the primary fuel tank, which is also the pilot seat, which I thought was kind of interesting. I thought that this was some kind of relief tube when the pilot had the whatever scared out of him doing a low-level mission over the trenches. But this is actually a channel for the push-pull tube for the elevators. So there's a push-pull tube off the stick that goes through here, connects to a bell crank aft that has cables going back to the elevators. So there are actually cables in the flight control system, just not inside the cockpit. So the wings are where I spent most of my time. This is 58618, the identifying mark being the big dent. That is not, it took me a while to figure out that that was actually a U.S. Army personnel hat and not some object attached to the upper wing. That's what you go for being a little too insular. This is once again a Villiers-le-Chevre, which is right on the Belgian border, by the way, before it came here. So the wings were of interest enough, apparently not the fuselage, that the U.S. did a lot of investigative research into the wings. Once again, they were all metal. How did they work? And there is actually an air circular, I think it's number 286, I give it later on, that is an analysis of the structure and says that it's a model for the production of metal-winged aircraft in the future, and this was published 1920. So it's interesting to see how it worked. They're complex. It's a spider web. The way they basically treated it is that there's no conventional spars or ribs in the airplane. The spars, of which in the J1 upper wing there are 10 spars, define the shape of the airfoil. And the skin is then placed over that to give a better shape of it. So there was a lot of work done to provide a structure to support those 10 relatively small diameter spars in accurate relationship to each other. And that was done with short lengths of aluminum, sometimes two, sometimes rolled C-section channels, held together with steel brackets and riveted. Everything was riveted here. And just like I showed on the fuselage, they are steel brackets formed and riveted onto the spars. The intriguing part to me is this section here. So when the aircraft was shipped, the outer wing panels were removed, but the upper and lower center sections were attached to the fuselage. And there are couplings involved that join the spar ends together between the center section and the wings. And every spar has one of these. And what you have is you have a female section, which you can see the female part here, which is the cup part of it. The male section has a ball on it. It's threaded on the outside, and it has this external coupling ring, which goes together, and they're all threaded together. They use a pin wrench. They're drilled through in half a dozen places and use a pin wrench to tighten up. They were all predefined at the factory for rigging, so there was zero rigging done in the field. All you did was mate the wing up, do up all the couplings, your airplane was rigged. These, by the way, for those who are interested, are made out of forged steel and then machined. And one of the losses to aviation was in the 1940s, Junkers trade school at Dessau was bombed into non-existence. And they hedged a huge technical library, which was mostly three-dimensional models and displays, showing technology from Junkers' 1909 research all the way up. Flying wing concepts, why he ended up with corrugations in the wing skins, et cetera, et cetera. These are some of the patents involved. And the ones of interest to us are these are different methods of how the heck do you buck a rivet inside a tube. And what they are is I originally thought these were like cam-driven hammers driving it. What they really are is that they're bucking bars. So the rivets were driven from the head down, and if you one hand here rotating it, so as it's bucked, the cam moves it up and displaces upwards with the displacement of the head of the rivet. He did develop blind rivets, and one of the repair kit accessories that went with the airplane was a blind rivet tool. I have yet to find a picture of what that looks like. And just on this page, this, by the way, is a book that was published in 1937 from the technical school, which I was fortunate to get a copy of, that shows a lot of the major patents. It's fascinating that it's all about Junkers and rarely mentions Hugo himself inside this. But over on this side are some of the early experiments he did with that ducted radiator. When I was talking about the underslung radiator on the J1, this is very much what it looks like here. This is a little assemblage of one of the US engineering division drawings. There are actually 6 drawings that still exist of the wings. Though all I've ever seen is copies. I've never found a source for them south of the border. Ottawa has these, which I have copies of. And what they did is they mapped the center section and the outer wings, upper and lower, not a single fuselage drawing, as far as I can tell. They weren't all that interested in that. But I was amazed, once again, I keep coming across these U.S. Army Engineering Division drawings of aircraft, and I would love to find the mother lode one day. So there actually is enough information if you wanted to build J1 wings. This is I wasn't hanging from the ceiling. A Canada Aviation and Space Museum photographer took this, John. I don't know how you would do this. Suspended hang fly or something.
Drone.
What you can see from this is you can clearly see the spars in the upper wing. It's also a very good image of the camouflage modeling pattern used on the aircraft, which I'll touch on briefly. Here's that metal cover, and that's the bay where the cameras were hung when they were used. So, end of the center section, I'll go through this quickly. This is actually the fuel tank. Despite what I told you about the fuel tank inside the cockpit, it was a gravity feed system to the engine. So, to start the airplane, the pilot sat there with a wobble pump and pumped fuel from the main tank up into this header tank, and the engine-driven air pressure pump, which was used on most First War aircraft, was used literally to displace fuel from the main tank the pilot sat on up to this tank.
And if you look at the back of the picture, you can see where they got that picture from, that previous one shot from. See the cross beams?
Yes.
The camera up there.
When I took these pictures, well, no, this is done actually when it was in storage before it was on the floor. That's just a picture of the tank. I thought the tank was interesting. So here's an idea to give you a sense of the complexity of the wing or the center section. The difference in the wing is every bracing member is a tube, flattened at the ends, a very nice mouth, and riveted to one of the steel spacers. You can see the ends of the couplings here quite clearly. You can see the inside of the corrugated skins. This is the aileron control tube, which is pushrod operated, as I mentioned earlier when we we're looking at the front cockpit. And that is the connection that would have a pushrod going aft to the aileron itself, which is on the outer wing panel. This is inside a wing. And what is notable is that they aren't tubes anymore. They're C-section rolled tubes, and it's sort of like a classic C, where it comes around but actually goes in on itself. It's almost 270 degrees right at the lip here. This section here is a flat piece with flanged ends riveted to the side. That's midsection on the tube and riveted onto the steel connecting plates. The skin is the most interesting, or one of the most interesting things about the airplane. It's unbelievably thin. While Junkers was able to get duraluminum for the actual structure of the aircraft, they could only get basically what we would consider 1100 grade aluminum for the skins itself. And it didn't provide the strength he required, which is the reason for the corrugations. There needed to be some strength to maintain the shape. It wasn't structural for the wing, it was to maintain the airfoil shape when the aircraft was flying. These skins are 0.3 of a millimeter thick, which is about 15 thousandths of an inch. That's why there's so much damage on the wings. It's literally just, if you went up and leaned on it like this, you would put a dent in the skin. And the operating handbook is full of cautions about how to transport, how to move, how to handle the wing sections because of how delicate they are. So this shows a section of wing, of skin. This is on the upper wing, just aft by the aileron. These panels are about 35 centimeters wide, about 13 inches overall. They're all uniform. It's a single panel that goes the full chord of the wing. And we think of them as being like a sine wave, a nice shape, and they are mid-span, but at the ends they're definitely not. At the ends they're absolutely flat, and you can see how the beginning of the corrugation is let into them. Now this is the trailing edge. The trailing edge is different from the leading edge in that it's very blunt. The leading edge is like this. You can see it's been pulled together to a point. And once again, the metal is absolutely flat between the beginning of the corrugations. So I've seen drawings from Junkers that show roller assemblies for rolling the corrugated work. There's not an inkling about how they started or ended a sheet to be able to do this. Also in the picture is the leading edge. That's 0.8 of a millimeter, a little thicker, 32 thou. Aluminum rivets in the wing structure. So the aluminum to the aluminum, as far as the wings went, was done with aluminum rivets. In the actual primary structure itself, it was always aluminum to steel with steel rivets in this airplane. Ailerons, full span for the wing, but not the center section. This is an interesting little gap filler, which is basically hinged along its full length with a single pin hinge, commonly used still on aircraft. Another reasonably good view of the color pattern on it. End of the aileron, showing it's a fabrication made out of two steel stampings that are just welded around the edge and then welded onto the aileron tube. What I wanted you to note here is that the aluminum is shiny. And it's not so notable on the outside of the airplane, but when you look inside the wings, and these things are 95 years old, and the tubes, the aluminum tubes, look like what you'd sort of expect of 90-year-old aluminum. They're sort of gray and slightly, not quite powdery yet, but they look like that. But the inside of the skins are shiny. And apparently they were treated with some type of lacquer. I mean, if nobody had told me it was that old, I would have said it was clear anodized. There's virtually no signs of degradation of the skins on the inside because of this clear lacquer coating that was used. Over here is showing the hinge assembly. This is one of the rear spar in the wing section. and this is the hinge on the aileron itself. See the counterbalance going off here? I've run out of time, haven't I?
No,
Okay. And comments on color. I'm not a color expert. All I can tell you is what I've seen on stuff. And this pretty much agrees with what everybody thinks. There's sort of a very dark purpley color offset by a near mossy green. And everybody tends to agree that's sort of the colors that these were, and that's great. My problem has nothing to do with the top of the aircraft, it has to do with the bottom of the aircraft. So here you can still see the purple and the green in here. Every single printed reference I've seen for the J1 says that the bottom of the wings are painted a light blue. Now, this is where I sort of get myself into difficulties sometimes, and I'm going, that's great, and I love the theory, but these are the only surviving wings, and they're sand-colored on the bottom. I can't explain why. One person opinioned to me, oh, that's because the blue-white paint has changed color over time. And I said, well, what about the upper wing stuff? Why hasn't, quote, that changed from what people tend to think it is? I don't have an answer for this. I'm just tossing it out there that I find it interesting that it's still commonly held that this should be light blue, bluish white, where this airplane is very sand-like. And if you actually have a sampler with you, it's very much like Africa Corps sand camouflage color. Not that these ever flew inverted over Mesopotamia or anything. And here's a better picture of the lower wing. You can see where it's a very thin coating of color. You can see where it's been scuffed on. And similar to my first one, we're starting off with Junk 1, 586 in here. There are a series of markings on the airplane, which are more of curiosity. As you're probably aware, every part of an airplane before it was assembled and accepted had to be approved by an ILFIG inspector, and they always have ZAC stamps on the various components. So every wing spar in an airplane will have a separate ZAC stamp, and it will have an acceptance signature and date on it. And what I find interesting, if you have an aluminum wing that they've cut a hole on to put an aluminum panel underneath, this shows the date of manufacture, which is 3/9/1918. It was approved, I take it by somebody of approval at Junkers. This is the Junkers logo at the time. This diamond with the stylized J. The ZAK stamp is down here, followed by the signature in pencil, which is not quite legible to me. The other thing we have is, what is my understanding, is the work number. And what it says is 0.M.129. I don't know what the 0 and M stand for, but then it says 129. This is off the fuel tank. Clemens Human was a fuel tank specific manufacturer that started about 1908 and was in operation to 1949, doing primarily fuel tanks. And you can see the work number of the tank, that it's for a J1. It's designed for a pressure of 0.3 of an atmosphere, approximately 5 pounds. It weighs 3.7, and it's 26 liters in the header tank, which at about 11 gallons an hour, or 12 gallons an hour for the engine is not a lot of flying time on just the header tank. And by the way, if the air pressure failed in the system, the pilot could happily sit there with a wobble pump. I've never heard a story about that. There are markings on the wing spars. I won't pretend to know what they stand for. They're just interesting. So we have OSL 29. The opinion of the curatorial staff at the Canada Aviation and Space Museum is that these are markings that were on the aircraft They tend to believe that they are factory markings because it was not common at the time when you were shipping war trophy parts that you would bother taking the care of marking it on the inside. You just slap something, usually in chalk, on the exterior of the object so you could identify it. TN something or other, 1580. Once again, no idea. Ponder it. If you come up with a good solution, let me know. JFA, handwritten on the inside of the skin, the little Junkers logo. And this one, this is 2-1-5, which I have actually seen in print as referring to the factory production number for this airplane. This is the accession number, given it to it by the War Trophy Board in 1919. So just to dispel a slight bit of information. We have good records on that. It's on numerous different parts of the airplane. If you want to build one, there's a reasonable number of bits of information out there for you. As I said, my favorite is the instruction manual for Junk J1 Armored Biplane, which was translated in 1918 by the Air Ministry. There's the Air Ministry report on the Junker all-metal armored biplane type J1, oddly enough in July 1919, after the war. And it's an interesting article because most of it was taken from one wrecked airframe. They didn't have a complete airframe of their own to be able to go over. There's McCook Circular 239 that I talked about earlier. The Army Air Service Engineering Division drawings dated 1920, of which I said there's 5 or 6 in existence in Ottawa. I don't know where else they are. The NACA report on German aircraft development, and the book I referred to, which I said 37, is apparently 38, is Die Junkers Lehrschau. John's asleep, so he can't correct me on that. And there are a lot of other references to the aircraft after that. These are more or less the only first-hand ones that I've come across outside of compilations. Windsock has extremely good articles, etc., on the airplane. That's it.
Great.